Hi folks, welcome back to the Metal Mill 52 workshop. My name is Bill and I am pleased to report to you that all of the major machining operations are basically done on the Quorn. and if you'll stay tuned for the next probably half hour or so, I haven't totaled up the segments, but I'll show how I made this aluminum motor bracket and fitted it to the Mark I wheel head. This came from an old piece of machinery which is sitting over there behind the propane tank, and you'll see me cut this out and then lay it out and machine it and so forth. So anyway, this is, as I mentioned, this is the last major machining operation, and I'm showing you various photographs of the bits and pieces. So there's still a ton of work to do in the Quorn. There's the 5C tool head there. But my game plan overall, all along I should say, has been to machine the thing, test fit it, get all the major operations done, and then I could relax and take my time by bit fitting, test fitting, fine-tuning all of the interactions that have to get done to make this thing a really good and usable tool. So what I've been doing just now, I just did the mock-up and I've made a list here of some of the key measurements. I was deciding whether I wanted to buy one of the Mark II belt guards and grinding guards there. I don't think I'm going to for now. Maybe later at some point, especially the grinding guard. I can kind of see that, but we'll have to wait and see about that. I think my distance is too long for the belt guard, but there's a whole bunch of other stuff that I've put down on the list. For example, on the rotating base, I never did degree that thing. I need to do that, mark it with degrees like you see on some of these the tool heads. And a few other things, just the thimble on the left hand side, I need to stamp the numbers on that. It's not assembled right now. And of course all the fettling, paint and body work, grinding the cast iron down and priming it and painting it, filling it, prime and painting. So, and buffing, shining things up, shining up the stainless steel. I like to put a coat of wax on all that stuff. So here is my kind of test assembly. And I've got it on a nice butcher block. I'm not sure if I'm going to use that butcher block for the final assembly when I have the machine completely done, but it looks pretty nice on there, so that might work. Over to the side here, you see I've got my little fishing tackle boxes with the rest of the ball handles that need to get installed. Part of the process will be making some custom brass bushings for all of these places, like this one is here, but for all of these, so that the ball handles tighten up at exactly the right spot. So there's still a ton of work to do for that. And fitting, I'm going to show you over here. In this box I've got the springs that go in the front bar. The thimble assembly is down here, and the ball bearings and so forth. So there's a ton of little detail work, and I'll bring you along for some of that. I'll try to make it interesting and show the process overall. But again, really excited that the major stuff is done, so please stay tuned, and I hope you enjoy the showing of the motor mount bracket and the rest of the details. And thanks for joining. If you're a new subscriber, I appreciate you. Please give me a thumbs up, pass the word, and let me know how you like things. I appreciate it. And as I mentioned in the last segment, the next step for me to do is to figure out the motor mount. And as you can see, I've got the Mark I style castings, and the motor I have is actually more suited to Mark II design with the small center shaft and then the 4 mounting bolts rather than a base mounting. So there's a couple different ways I could do this. I could try to fab up a little base mount thing for the round motor and just not use these tabs. But what I have in mind is something a little bit different. I think it might work out pretty well. The first thing I did was to cut out this cardboard template. As you can see here, pretty good representation of what I have in mind. And I made a list over here of some of the design considerations, things I needed to think about. One thing I haven't done yet is to drill and tap any mounting holes in the back of this. I did that on purpose when I was first machining this because I wanted to see what, I knew I'd have to come up with something custom for this. So anyway, where we are is something like this, and what I got to looking around for different things in the shop, like big pieces of angle iron, and obviously it would take a real big piece, like a 3" by 3" piece by about 3.5 inches tall to accommodate this need. And I didn't really have any angle iron that big, but one thing I have, and my buddy Alan will recognize this if he's watching, that years and years ago, he and I took apart a bunch of old medical machines for parts, and some of which you saw that I used on the Gingrey shaper. I've saved this particular, this is a giant aluminum casting that was a machine base, and as you can see here, it's got a big piece of angle aluminum in there. It's about 1/4 inch thick here. So I'm thinking this would be kind of perfect, but I'm going to have to liberate it from its confines, so that'll be a tricky deal. I'm thinking I can use my power bandsaw, portaband, to cut it out. So without any further ado, I'll set this aside, rearrange here, get ready, and set up the saw and see if we can cut that part out. Now I've got the big casting set up in the old workbench that I have, Black & Decker Workmate. I really like these things. I got 2 of them, and this one's in need for some refurb, but they work great for holding irregularly shaped items. And I've got my portable bandsaw here with a fresh blade on it, so I'm going to take a few minutes of video of trying to liberate certain sections of this thing. We'll see how good it comes out. It's probably going to be kind of loud and screechy and irritating. Well, matter of fact, if I have that angle, you're not going to see a dang thing. Tell you what, you can see the setup, you can see the portable bandsaw here. Rather than me, I think my body's going to be in the way of the camera the whole time if I try to take that. So let me just get started on this. I'll bring you back when I have some progress made. We'll see how it works. What I did was I stopped a little bit from the edge so I could take the saw out, and I'm leaving a little bit connected so that I'll be able to, kind of like a plastic model kit where all the parts are connected with one little snap, you know, on the tree. So next I think I'm going to make this top cut here. I'll leave a little bit connected there, make this cut over here. So I won't bore you with the whole process, but looks like it's working okay so far. Okay, I made some good progress using the portaband bandsaw. Got a few cuts I'm going to have to make by hand because of the tight squeeze here. I thought just about through this one I can bring you along for that, and it's not too loud. Easy for me to say. Of course, I'm using some WD-40. I've put it in these spray bottles that my wife collects for household stuff. It's very handy that way. Just about through this part. I'll stop and show you what I've got. going to be a clang fest for the last few thou of cut there, but as so far I've got this part all the way cut through, this part all the way cut through, and this part here all except for about 3/4 of an inch. So when I finish this cut, this kind of a relief cut that will free these pieces up, then I can cut this part by hand. I did the rest of it using the portaband. Then I'll have to flip it over and do a bottom cut. I'll bring you back for that. Alright, I couldn't resist. This should be the last tiny cut right here. I'll be able to free up the entire piece. Let's take a look. As you can, maybe you can... Oh, there we go. Well, magic. Looks make me think of something like from there's a classic This Old Tony episode where he cuts metal using WD-40 because it repels water. Anyway, silly me. Look at that. That's going to be awesome. I'll have to do a lot of trimming and cleanup and so forth, but really excited about how that thing looks. So now that I've got it liberated from the shell, I can clean it up, deburr it, and use my cardboard template to actually lay out and start thinking about some of the machining steps that will be involved. So this is, to me, it's just almost identical to using a casting that was purpose made for the motor assembly. So my idea, of course, this part would get bolted, machine screw, whatever, to the back, the Quorn motor head, and this part is where the motor itself will go. I'll keep you posted. Well, it's Tuesday night, and I took last night off, took Monday off, and what I've done so far, I've taken my little cast angle piece, and I cut the little nubs off on the bottom there using the bandsaw. You can see them down here on the floor, and also cleaned up the angle right here, and I'm cutting off this extra piece, almost done, so I thought I'd stop and take a picture of it. So that'll just save a lot of the machining time as I machine this back to a square, or a right angle rather. And I wanted to point out one thing about this. It's not unusual with castings to see irregularly shaped walls, so it's what they call draft. I think it enables the casting to be removed from the sand mold or whatever they pour the casting in. So you can see the wall thickness of these pieces is not exactly consistent. There's a little angle to it, a draft angle it's called. So what my idea here is to cut off all the irregular parts, and then I'll be able to put it in the vise and then machine it to flat surfaces and right angles to each other. Alright, so here's a successful effort in cleaning things up. Got the little feet cut off there and the flange basically cut off with the bandsaw. And I've got it in the vise. As I mentioned, it's irregularly shaped, so I've got my patented ball bearing and a nut pressing on there, so I got a secure and angle accommodating basis, if you will. I'll probably put some more additional clamps, some finger clamps on the top part here. My first step that I have in mind anyway is machining this surface flat. Then I'll have at least one datum to work from. If all goes well, then I may also side mill this side, clean that up, so I'd have the flat and then 90 degrees to this part, and then I just have to reposition to machine here and clean up the edges. I guess while I'm at the bottom, I could also clean up the base a little bit too, so we'll tackle that next time. Just thought I'd bring you up to speed on this. I'm about finished with cleaning up the base. And I'm not going to bother milling this part off because I'm going to cut that off on the bandsaw anyway. I've got this cleared off flush and it's looking good. Okay, I've got the angle thing. I cut the bottom off like I showed in the last video, and just excuse me, hit it with the belt sander a little bit. Now I've got it in the mill. I'm just going to level off the tops, just take it down even, and then I can mill the outside so it'll be at a good perpendicular angle to this surface here. a lot of ordinary stuff. I'll take a couple minutes of this. I don't need to belabor the point, I don't think, with y'all. Got my 0 setting. Since this is a regular shaped object, I've got it held in with 1, 2, 3 blocks there. Around about 50 thou. Another 50. I have some WD-40 sprayed on there as a cutting fluid. Could use a power feed. Oh, not turned on. I have my power feed plugged into the same circuit breaker that I use for the DRO, and that's it's not plugged in right now. Do that on purpose. So we get a lot of lightning thunderstorms here, and I don't want to fry any of the electronics. So everything's protected by a power surge bar. Okay, you get the idea. I'll bring you back when this is complete. Now we got the top cleared off now. Just need to machine this surface flat here, so I'll be using the same cutter, just going straight down with it. I don't think I'll bother videoing all that. I'll show you the result when we get done. Alright, got a mountain of aluminum swarf and got the dang cutter stuck out way longer than it ought to be, but sometimes you got to come up with some creative setups. But this should be the very last pass, I'm thinking, and we'll have this part cleared off very nicely. Cutter I used extensively for building both the Gingery shaper and the Quorn. So when I do get the Quorn done, this will be one of the first cutters that will get some resharpening attention. It's definitely going to need it. It's really a good one. Alright, there we go. I'll cut this off. I still have a little noise because of the rotary phase converter, but so now this is nice. I'll sand that to get a nicer finish on it, but at least it's all flat, and then it's going to be perfectly perpendicular to the outside edge here, which is up against the fixed jaw. So my plan is, I'm thinking that this side is going to be the one where the motor is, and this side will be the part where it gets mounted to the back of the wheel head. And I'll probably just use some countersunk screws to go in there. The motor will be here. I'll leave a little space with the countersunk screws. And I have an idea about actually allowing the motor to pivot a little bit like you would an automotive generator or alternator. So as a way of tightening it up. So we'll see how that goes. If I do that, my point is this surface, which is at an angle, the inside surface is at an angle. If I can figure out a way to machine that flat, that would be helpful, so that the motor does not get canted if it twists. We'll see how that goes. Okay, the basic machining is done on the angle plate that I liberated from the old machine base. And as you can see, I've mocked up the holes. I used my little cardboard template there. It's a good thing I made that. It really helps you visualize where the holes would be. And so this is what I have in mind, having this part connected with machine screws to this base, and it'll probably be more like this. So just having the template, I'm able to lay out the holes, and I can see that that is way too close. There's not going to be enough room for the machine on the end. If I had the holes where the cardboard template initially would have led me to put them. So pull out a little bit here, show you the motor. What these marks are here, these are Sharpie marks for probably where the closest center line location would be, which, as I mentioned on one of my previous videos, I do need to have an adjustment way for, or one of the previous segments rather. I need to be able to move the motor out to tighten the belt up, or I'll need to be able to rotate it a little bit. So if I'm able to, I want to play around with some ideas, but it would be kind of cool to have one fixed slot, one fixed hole for a bolt hole at the bottom there, and then have the other three be like arcing slots, so the motor weight that could be used to tighten up the pulley a little bit if need be. So not sure that that's going to be necessary or even doable, but if it could be, that'd be kind of cool, and I could see how you do it. I mean, you could just place this in the, drill your initial holes for locations and make sure it fits good, and then just put it on the rotary table and have the center of rotation here. It's not a very good light here. Have the center of rotation, if this was the pivot bolt per se, which of course it's all going to be need to move down here to clear all this stuff, but have one regular hole for the pivot, and then the other ones would be arc shaped, so you could have the center of rotation on the rotary table there, and then just move your little end mill out to the various spots and rotate the cutter in and make an arcing slot. The other option, of course, is just simply, instead of drilling 4 plain holes, have 4 holes that are converted to longitudinal slots. And in any case, the center hole is going to need to be a little bit bigger than the shaft, but should be fine. Looking good. Excited about that. Okay, here is sorry about the dogs barking there, but I've laid out the pattern for the holes for the motor, and I'm planning on making a larger center hole anyway, and it doesn't really matter. The other I scribed a 1/2 inch arc around the other holes, and assuming perhaps that this one is the pivot one, and then I'd cut an arc for tightening. Then this one goes up, this goes up almost straight up, and this one kind of goes down. If this is the center of rotation down here, that kind of makes sense. So we'll see. I'm still not convinced. What my plan is right now, to put this on the mill and go ahead and drill the holes in the spots and kind of see what it looks like. And a big thing, part of the equation, whether I end up drilling the arc spots, and having it pivot, or just milling straight lines is the fit on the milling machine with this flange part here, because as you can see it was a tight squeeze to get the milling cutter in there against here. So it might just be easiest and cleanest just to mill some slots for the to slide the motor out to tighten it. We'll see. And back at the mill, I went ahead and drilled out a 3/4 inch hole in the center, and I've drilled out 3/16 inch holes for each of the motor mounts there. Still not sure if I'm going to try to do the angle thing or not. We'll find out. I'm going to do a test fit right now, and then we'll consider it, and I will bring back and brief you. It'd be obviously a heck of a lot simpler just to replace the drill chuck with a milling cutter and mill straight slots, but we'll see. Alright, here's the mounting plate, angle plate on top of the motor. Perfect fit. Very happy about how that came out anyway. It's too bad I can't just call it done and then drill some holes in this to mount to this piece and rock on, but I do need a way of tightening the belt, and a couple of things occur to me now that I think about it, in case you're wondering. I mean, I could put a hinge here, like a little door hinge, and have the weight of the motor flop down and put tension on the belt itself, but I don't really like that idea. I'm pretty much sure I'm either going to go with the slotted holes, where I could just push the motor over and tighten them down, or go with the angled holes. I guess I'll get the rotary table out and set it up. You know, there's going to be interference because of that flange on the one side. I'm not going to be able to get an end mill down there all the way, but I guess there's a couple of options there. I could use that as my mounting hole and then have the other ones be the twist. That's a thought. Anyway, I'm going to get the rotary table out, set it up. Couldn't hurt to take a look at what the setup looks like, and that'd be kind of a cool, elegant solution, you know, to have the angle, the slots that angle and rotate. We'll see. Well, as you can see, I've got the rotary table in place. I set it at 0, on the DRO, and then I just put the angle plate in place, and as you can see, it's held up on a couple of blocks, and I've got a 3/16 inch drill bit in there to mark my center. So from here on out, now all I'm going to do is move the table so that, and as a matter of fact, I'm using this one. I originally was going to use this as my center of rotation hole, but I decided to use this one because I can reach in there with the drill bit, whereas I wouldn't be able to hit it with the end mill because that angle plate's going to be in the way. So now from this point on, I'll just use the drill. The drill is held in a 3/16 inch collet. I'll just move the table over here so I can center this hole, and then I'm not going to touch the DRO or anything. I've got my 0 set on my rotary table, but so this will stay my 0, and I'll just move the whole move the drill over till this is centered, and then I'll replace the drill with the end mill, and then I'll just mill with an arc using the rotary table. Hope that makes sense. I got 2 of the 3 arcs cut so far, and it's going pretty well. I thought I'd try to video a little bit of it, but here I'm on my 3rd hole. I'm using the end mill to center it, and I'll put in my first depth of cut. Going about 100th thou deep here. Squirt on a little Happy Juice and WD-40, and I'm just cranking in. I'm making the arc 20 degrees, which I think is more than enough to give me, you know, a ½ inch of movement or so for tightening. So we'll see how that goes. Hopefully you can see the end mill cutting. Moving the table very slowly. Dust some of the chips out of the way there. Sharpie marker to mark my 0. So there's 10 degrees of cut. Dust this off. That's how each of the cuts looks. Go down a little bit more. You get the idea. I'll bring it back when it's complete. Okay, since I went to the trouble of trying this idea, I thought I'd take a video, real quick segment here showing the scallops and the little adjustment slots for rotation. I sure hope I figured this correctly. We'll see in a minute when I take it out and try it on the actual motor itself. For this one, it looks like I made it a little long, but I could have sworn I only made that 20 degrees. So anyway, we'll see when I take it out on the motor. But that's what the setup looked like anyway. Okay, not too bad. The test fit, this looks good. The one thing that I really hadn't thought too much about was the center hole. And what I'm going to need to do is put the plate back in there and mill the center hole out at an angle as well, because it makes a nice, that 3/4 inch hole that I drilled before makes a real nice nest for the center of the arbor there. It's kind of a shame, but one way or the other, I mean, you got to be able to tighten up the belt. So I'm going to make the arc in that as well. I'll use a 3/4 inch, just like I did for the center hole, and we should be fine. Okay, I thought this might make a cool segment, the machining the center hole. Let's see. I guess I already got this a bit. It shows you the arc. You mark the 20-degree endpoints in blue Sharpie. Makes it a little easier. Yeah. Lock it, slip the bit. It's taking 50 thou of the time off. Probably cut a lot deeper than that, but I'll show you the 3/4 inch on there. I'm taking my time trying to enjoy the process out here. I'm getting close. Bring it back. Cutter out, brush off the chips, let's see what it looks like. Okay, nice little oblong hole. But I think that'll work. I'll deburr it, I'll unbolt it, deburr it, and we'll do another test fit, and I'll bring you back to that. Okay, I had a little issue. I put it back in the mill, and I milled out the center hole just a wee bit more, and as you can see now, you can see all the bolts that it rotates all the ways through, so I should have pretty good tightening from this. We'll see when push comes to shove and the actual thing is in process, but it may take a little jiggling. It's kind of hard to do it with one-handed now, but you know, I don't think it's going to take a lot of twisting to get the tension that I need. So I think I have good movement. I'll file these holes just a little bit for smoothness, but as you can see, it does move all the way through the arc. So hopefully that's a good solution. Okay, after several test fits, as you can probably see, I had to file out the arched holes, whatever you want to call them, because there was some interference with the pins. But I thought I was already done. I still got some oddball interference. Then I realized it's basically this little section here that I've marked with the Sharpie. So I'm about to cut that out with the bandsaw, and hopefully the fit will be fine. I'll show you that in just a second. Alright folks, so that was successful. This is the little part I cut out right here. We just cut it out in the bandsaw. So I'll need to sand that down a little bit smoother. But what you may be able to see, that it was actually interfering with part of the motor shroud, so that's what was causing some of the resistance. After I filed out these slots, I probably would have, if I could do it over again, I would just make the slots a little bit larger. These studs are only number 8, and I used a 3/16, which I thought would be plenty of spare room, but not quite enough. So I did have to file, and I used the little Dremel with the little grinding carbide, 1/8" carbide to grind out, smooth out each one. But it rotates smoothly now, and I'm very happy about how that setup works. The next thing to do will be to figure out the actual mounting here. But now that I've got this on here, I'm going to put the pulley on, and I'll be able to play with the adjustments and see where we need to put the holes, because I haven't drilled and tapped anything in the back of there or in the back of this one yet. So that'll be the next step. I found the Blue Max round cord that I plan on using to power the Quorn grinder head, and I've put it in line here just to check my setup. So I think this is going to work out just fine. I've got this edge flush here, so now it's just a matter of marking out where I want to drill and tap the holes. And I think I'm going to use hex head 1/4-20 with lock nuts, because if I use those, then I can reach in there with a wrench and unfasten this without taking the motor off. So now it's just a matter of marking everything out, drilling and tapping, drilling clearance holes in this side, and then drilling and tapping into the back plate. Okay, this part of the process was a little clunky, but I did drill the holes in here, the ones that I could fit anyway, with the tapping size, the 13/64 tapping size for 1/4-20. And then I've set the wheel head in place in the mill, in the mill vise, and I'm using a transfer punch to transfer the holes so I can drill the tapping size holes inside the cast iron and tap them out. So I'm just going to proceed and get this done without taping the whole process. Okay, so that worked out. There it is, all assembled. I'm really happy with how it came out, and I think it was worth the effort of cutting out that piece of aluminum. I think I'll leave this excess on here for now. You never know. I mean, it could be handy for some purpose. So we'll see how that goes. But those are the quarter. Here, the reason I use these regular hex head bolts is so I could unfasten this without taking the motor out. I had intended to use some nice countersunk 1/4-20 screws in here, but then I realized I'd have to take the motor out every time I wanted to take that apart, which probably won't be that often, but you know, didn't want to have to hassle it if I could get around it. So thrilled with how that has come out. I'll be cleaning it up. I need to take it all apart and sand and grind and file and get it prepped for finish. So I think we're getting to the point, we're getting close to final test assembly and paint and body work coming up pretty soon, everybody. I'll keep you posted.